In this slide, we are going to describe the Newton method for a system of nonlinear equations. For a system of nonlinear equation means we have more than one nonlinear equation. Suppose the first nonlinear equation is a1x1 plus a2x1 square plus a3x2 and a4. Several variable we have with the linear and non-linear values, and we have some number here. This is the first equation. In the same way, we have another equation, b1 x1 plus b2 x2 square and so on is equal to something, and so on. We have several such equations. These are called multiple non-linear equations we have. And what is the objective of this? We have to find out all unknowns. We have to find out the roots of this system. Unknowns are what? The values of x for which the y is 0, which are called as x-intercept. At x-intercept, the values of y are 0. These are the two intercepts, two x-intercept. The value of y is 0, the value of y is 0, the value of x is basically the root. So we are going to find out the root of this system with the help of the Newton method. So we are going to implement the same procedure as described earlier for one equation. So what was that? That was very simple. The first initial gas is there. The first initial gas is not a single value. It will be a value for all variables. Suppose I have 5 variables, x1, x2, x3, x4, x5. Then initial gas is what? Initial gas is a vector. This vector should contains as many value as there are the numbers. So x naught. So x naught is a vector, the values of x. And the next thing is what? Fx. Fx is a vector containing the all equations. So what are the equations which are given to you? You have to write down the all equation in a vector. That vector is known as and represented by fx. F dash x can be computed with it is a matrix. How f dash x is computed? F dash x is computed by taking the derivatives. The derivative of the function 1 is taken by x1. So with respect to x1, you have to differentiate this function. The first entry of this matrix is this. The derivative of the first function with x1, the derivative of first function with x2, and we have as many columns as there are the number of variables we have. Suppose I have only 4 variables, x0, x1, x2, x3, then if we are representing by starting by x1, so these can be represented by x1, x2, x3, x4 instead of x0. So we have the four variables, x1, x2, x3, x4. So we need the 4 equations to solve the system. And these 4 equations are placed here in this vector. And these 4 equations are differentiated by, first equation is differentiated with respect to x1, then first equation is differentiated with respect to x2, and so on. The first equation will be differentiated with all of the 4 variables. In the second row, we have to differentiate the second equation with respect to x1, x2, and so on. In this way, we will get a matrix which is known as the matrix of derivatives. So this is a vector, this is a matrix, this is the vector in which we have 4 values as the initial gas. Suppose I have 3, 1, minus 2, 4. These are the 4 values which we are using as a initial gas. So what was the formula of Newton-Raphson method for a single equation? The formula was xi plus 1 is equal to xi minus f of x divided by f dash x. So as all things are in matrix, so we do not have the division sign there. So the formula is updated. How the formula is updated? This can be written as it is equal to xi minus f dash x power minus 1 inverse, because it is in division, multiply by fx. So instead of division, I am writing it as a inverse. In matrix, we have an inverse. So inverse of this matrix is to be computed. After calculating the inverse of this matrix, then it is multiplied with the variable f of x k, which is the function value at the kth point. Then it is subtracted from xk, then new iteration is obtained. So the old iteration, and this is to be subtracted from the old iteration, the new iteration will be obtained. The procedure is to be continued till we have a specific number of iterations to be completed, or we have to be stopped at a specific level of error. So these are the two criteria that is already defined with the for completing the iteration in a Newton-Raphson procedure. Now a system of nonlinear equation is given to us, and we have to solve the system. The two equations are given, and the two variables are there. One variable is x, other variable is y, and an initial guess is given to you. The initial guess x value is 1 and the value of y is 0. There is a possibility that this initial guess will give us a solution, or there is a possibility, other possibility is what, that will not give us a solution, means divergence will be there. So we have to follow the procedure. According to the procedure, we have to write down the initial guess in a vector form. We have to write down the system of linear equation into a vector form. And then we have to calculate the derivatives, the derivative of the first equation with respect to x. We have to calculate the partial derivatives. Then we have to calculate the partial derivative of the first equation with respect to y. In the same way, we have to calculate the first derivative of second equation with respect to x, then first derivative of the second equation with respect to y. So we have the four derivatives, and these four derivatives are placed in a vector in a matrix called fx. So what we have right now, we have the matrix of initial guess. That matrix is represented by 1, 0. Then second thing, what we have, fx. What is fx? Is the matrix of equations. The first equation is y plus x square minus 0.5 and minus x. And second equation is x square minus 5xy minus y. This is the second equation. Now we have to differentiate these equations so that we will get f dash x. And f dash x is what? Is the derivative of the first equation with respect to x. So here we have a derivative of the first equation with respect to x. Then here we have a derivative of first equation with respect to y. Here we have a derivative of second equation with respect to x. In this place, we have a derivative of second equation with respect to y. These are the derivatives, means we have x and y in them. But after putting this initial guess into these derivatives, we have matrix of values. So we have four values here in this matrix. What is the next step? We have to find out the inverse of this matrix. All of you are already familiar how to calculate the inverse of this matrix. Inverse of this matrix is to be calculated. After calculating the inverse of the matrix, we have to apply the formula of Newton-Raphson method. That formula is what? Xi plus 1 is equal xi minus f of xi divided by f dash xi. But I have to write down the formula into the matrix form. Xi minus, whenever we have this in denominator, in matrix it will be represented as f dash xi inverse. So the inverse that we have calculated here is to be plugged in here, and it is multiplied by with fx. This fx is already given to you. Now multiplying this, these two will give us a vector of initial gas we have, it is 1 0, and another vector we have here with the two values, because when we multiply this matrix with this vector, we have only the one column. So we have one column here, we have one column here, subtract these numbers, we will have a new iteration. The first value of the new iteration, the second value. So this is the procedure. In the same way, we have to repeat this procedure multiple times. So it's lengthy procedure. I am going to show you the solution of the problem. Now, you can see the matrix and the vectors. The F matrix. F matrix, you have to write down the first equation here in the column number 1 and row number 1. And the second equation we have here, it is row number 2, column number 1. So this F matrix has only one column, and that column is the equation. Now f dash, the derivatives are computed. The derivative of this with respect to x. So the derivative of y with respect to x is 0. The derivative of x square with respect to x is 2x. So we have a 2x here. The derivative of 0.5 with respect to x is 0. The derivative of minus x with respect to x is minus 1. So that is why we have a 2x minus 1 here. Now the derivative of this equation with respect to y, that is the derivative, is to be write down here. The derivative of y with respect to y is 1. Partial derivatives we have. The derivative of x square with respect to y is 0. The derivative of 0.5 with respect to y is 0. The derivative of x with respect to y is 0. So we have only one here in this place. Now second equation, the derivative with respect to x. So x square, the derivative is 2x. The derivative of 5xy, we have 5y. And the derivative of y with respect to x is 0. So we have only the 2x minus 5y. Now the derivative of second equation with respect to y, the derivative of x square with respect to y is 0. So this is 0. The derivative of 5xy with respect to y is minus 5x. So you can see the minus 5x here. And the derivative of y with respect to y is minus 1. So we have a minus 1. So we have the four derivatives here. The first derivative is this, 2x minus 1. The second derivative is 1, row number 1, column number 2. The third, the next derivative is this, column number 1, row number 2. So we have the four entries in this matrix. It is a square matrix. This is one step. In the next step, I have to plug in these values into this matrix, so that we will get the matrix of figures. The value of x is 1. If we put the value of x is 1, so this will becomes 2 into 1 is 2. 2 minus 1 becomes 1. So if I plug in f dash at x naught means we are plugging the f dash at 0. So the 0 is to be placed, and that 0 is indicating what? That the 0 is indicating basically the initial point. So the value, what value will be there? The value, if I put 1 here, so 2 into 1 becomes 2, 2 minus 1 becomes 1. So this is the number 1. Now 1 is constant, so no change will be there. Now the value of x is 1 and the value of y is 0. If we put y 0, so this factor will become 0. 2 into 1 becomes 2. So we will have 2 here. If we have x as 1, and there is no y in this equation. The 5 into 1 is -5, and 5 minus 1 becomes -6. So we have a -6 there. So this is the matrix at derivative at x naught. Now we have to calculate the inverse of that. All of you are familiar with the inverse of that. Either you can use the adjoint method to find out the inverse, or you can use the new Gaussian elimination method, or Gauss-Jordan method, or simple adjoint method. So these are the different methods for finding the inverse. So we have to find out the inverse of this matrix. So these steps are here. You can see the steps. In these steps, I have calculated the vector matrix 1, 1, 2, -6. 1, 1, 2, -6. As I show you, 1, 1, 2, -6. This is the matrix that I obtain after placing this. Now this is the matrix, and we are calculating the inverse. So equation, how the equation is write down for the next iteration. The next iteration can be calculated by computing the inverse of this. That inverse is represented here. That inverse is multiplied by this vector. After multiplication, it is subtracted from 1, 0. We have a new iteration. The new iteration is 1.125, 1.25 and 0.25. So this is the next iteration. So in the next, if you got the next iteration, another iteration can be obtained by the same process. So what you have to do, you have to again differentiate the second iteration. The second iteration is shown there. You can see the second iteration, the value at the second iteration, f, and f dash, another derivative is computed, and the another derivative, after computing the another derivative, we have to plug in the initial guess. Initial guess is this. At the third iteration, this is the initial guess, the previous iteration, the value of the previous iteration. Then f dash is computed, the derivatives are computed. Inverse of these derivatives are to be calculated and multiplied by the value of f. This is the value of f. Now after product, we have one column. That column is subtracted from this iteration. We have the result of the next iteration. So we have the different levels. One at level number 1, that we have 0, 1, 1, 0. At level number 1, the initial value is what? 1, 0. The level number 2, we have the 1.25 and 0.25. This is the second vector. And at level number 3, iteration number 3, we have this. The same procedure is to be implemented so that we will get the small reduced error at the specific point. Now, any question, if any one of you have, you can ask. Now we have another example. In this, again, we have two equations. I think so. They are the same equations as we have in the previous example. 5xy minus y. No, this is the another set of equation we have. Not exactly same as the example number 1. So in this equation, we have two variables. Similarly, we have two variables here. So a 2 by 2 system is needed. Initial guess contains the two values. There is a possibility that the more than two variables are there. And if more than two variables are there, you have to be the values of the new variables you have, and the values of new variable can be determined with the help of the system. Now, f is written, how the f is written? F is written by representing all equations into a vector form. This is called vector because it is a column vector. It has one column only and two rows. So the both equations are written, derivatives are computed. The derivative of y with respect to x, 0. The derivative of x square with respect to x is 2x. The derivative of 1 with respect to x is 0. The derivative of minus x with respect to x is minus 1. Then we have to be calculating the very derivative with respect to y of the first equation. So the derivative of y with respect to y is 1. Because we are computing the partial derivative of y with respect to y, partial derivative. The derivative of y with respect to y is 1. Derivative of x with respect to x is 1. The derivative of so on. Initial gas is what? 0, 0 is the value of initial gas that is given. Origin. Step number 1, origin is there. Step number 2, 3, 4, 5. These are the values which are the different steps. So directly I am giving you the values, but you have to verify it or by implementing the all steps. So you have to implement the all steps. Steps are what? Steps are same. X1 can be obtained by x naught minus f dash inverse at x naught multiply by fx at x naught. In the same way, x2 can be obtained by x1 minus f dash x1 inverse and f dash fx1 and so on. In the same way, you have to calculate all. These are the iterations, and after our iteration, we have the value of x is minus 0.5 and minus 0.19. These are the values. You can verify whether it is a correct root or not. You can put this into the equations. If these equations will be the 0, 0, and these two values means this is the accurate solution. If that is not exactly 0, but very closer to the 0, we can say that is an approximate solution, and you have to move to the next iteration number 6, 7, 8, 9, and so on. So this is the completion of first segment of this lecture. This is comprised on solution of system of nonlinear equations with the help of Newton-Raphson method. I am going to close this video here.